3 dimensions, can't be 2 or 4 unless you live in flatland, and we don't. N equals 10 to the 36th, the ratio of the strength of the electromagnetism to gravity, such that if it was just a few less zeros, the universe would be too young or too small for life to evolve. The relationship between electromagnetism and gravity. The fabric of the universe, if there was too much featurelessness, if it was too even or too diverse, too asymmetrical, then stars couldn't have formed, therefore no planets, no life. And then finally, the cosmological constant, which sort of holds the universe together. Anyway, you get the idea. There's all kinds of numbers. It looks like it's fine-tuned. Okay. So what's the answer to this? Well, there's a little bit of what Carl Sagan called carbon chauvinism in the argument. Like, we think we understand chemistry and biochemistry, and this is the way life happened here, so we're pretty sure it couldn't happen under some other form of physics or chemistry somewhere else. And I think we're a little anthropocentric and egotistic and probably too ignorant to think of how physics could exist in some other structure. Maybe there are other universes in which something like matter could form and therefore life. It's a little, also, I find a little disturbing to say that, you know, life, the universe is fine-tuned for life. I mean, this is, nobody cares about stars or planets, it's us. Well, no, actually it isn't. There's hardly anywhere you can live. It's mostly empty space, and most of the matter in stars and quasars and supermassive black holes and all that, you can't live on those places. And most of the planets appear to be largely uninhabitable. So the idea that this is all here just for life, well, actually, no. I mean, in a way, you could say that makes their argument, right? What a miraculous creation it is here. Well, okay, we'll see about that. And then finally, I think, well, two finallys. There may be some underlying principle. This is Steve Weinberg's idea that, you know, we're so ignorant in physics still, even after 400 years. We still don't have a theory of everything to tie quantum physics with global general relativity. There may be some underlying principle, you know, the equation is supposed to fit on the back of the t-shirt, maybe it has to wrap around a couple times. But in any case, something that kind of unifies physics still hasn't been done. And Weinberg says, you know, it could be that all these little numbers everybody's so up in arms about may all just fall into place, and there's just one number. There may just be one mysterious number. And that needs an explanation. But that's far different than saying there's 10 or 20 or whatever. And then I like the multiverse idea, that there might be multiple universes, all with different configurations of laws of nature. I like this because it's Darwinian. And the argument goes like this. This is Lee Smollen's theory, and the Living Cosmos, I think is the name of this book, that any universe with laws of nature like ours gives rise to matter, atoms and molecules and stars and planets and so forth. And when stars, if they're big enough and they collapse into a black hole, and at the center of the black hole is a singularity, which is at least one theory of the origin of our universe, came out of a singularity. So it could be that when black holes collapse, they collapse into a singularity and create another black hole. Create another universe, a bubble universe that has laws similar to the laws that it had. So it's like giving birth. And the laws of nature are like its DNA that it passes along. And bubble universes that have different laws of nature that don't give rise to matter, don't have stars, that can't collapse into black holes, and therefore they go extinct. See, it's a nice Darwinian explanation. I like it. There's no evidence for it at all. However, the other side has no evidence either. So don't be taken back when they say, you don't have any evidence. Well, when did evidence matter for your side? A second point, the design inference. This is Bill Dembski's big thing, that if you go to Mount Rushmore, nobody looks at those big heads of the presidents and go, wow, that's incredible that erosion and wind and rain carved those. And yet we all look at the face on Mars, because it's sort of a grainy photograph shot by the Voyager spacecraft, and we laugh that the ufologists think, you know, Martians built that to signal us, and therefore we should go to Mars and talk to them, or something like that. We all know that nature makes these patterns. I call it patternicity, the tendency to find meaningful patterns in random noise. We all know that happens. So the question is, what's the difference between Mount Rushmore and the face on Mars? And their answer, Dembski's answer, is an intelligence was behind the face on Mars. Chance was behind the... intelligence was behind... It's a little hot up here. Oh, it's all right. who's that governor of New well, never mind.
Who's the block?
So, all right, so this is Dembski's argument. I mean, it's reasonable, right? This is what the SETI program is trying to do. What's the algorithm to detect, say, the difference between a rotating neutron star that sends these blips out and an intelligent alien who would send out maybe the blips of prime numbers? Well, that would be it, right? That would be the difference. If no neutron star is going to rotate and give us prime numbers. It just doesn't do that. So that would be a difference. Okay, that seems like a reasonable argument. Until you push them and say, well, what is it that would, what's the algorithm? What's the difference between, say, random molecules bumping around and self-replicating DNA? I mean, how do you know one is created and, say, the other one isn't? How do you know? They have no answer to this. What would be the way to do that? And also the problem is that, like, say, archaeologists might say, I can tell the difference between, I don't know, a hearth that's made out of bricks and just a random pile of rocks that fell off the side. Yeah, okay, because we have experience of people making things. But how can you tell the difference? It's a little grayer. If, say, the difference between an Australopithecine hand axe and a rock that just tumbled down the hill that's kind of chipped on both sides. There has to be something of a symmetry to it. An archaeologist who's experienced looking at these things could, yes, infer that there was an intentional chipping because it has sort of a scalloped and consistent symmetry to the way it was chipped versus the randomness of the stone that just rolls. There has to be some way to tell the difference. And the intelligent design guys have yet to give us the formula for whatever it is. The eye, the bacterial flagellum, blood clotting mechanism, whatever their favorite X is that they feel we haven't explained yet. And then finally, the explanatory filter, the idea that kind of inferred from this that, well, this is really kind of the same thing, really. It's just, how do you explain complex adaptive systems that rise from simple to complex? And again, they're just looking for some kind of difference between chance and directionality. And of course, all scientists are looking for that. But until you actually have some kind of testable way to do it, you give us the mechanism that you think is working and then we'll test it. Then they're still not doing science. So when I push them, for example, and say, okay, let's say we allow intelligent design to be taught in public schools, science classes, what are you going to teach? And this is really gets them, rather than debating them about whether it should be taught or not. I just say, okay, go ahead. It's an 11th grade biology class, or whatever, 10th grade, I guess, when they do the biology with genetics. So what are you going to teach in the genetics section? Well, we would say, something like DNA could not have come from RNA, and RNA could not have come from the pre-RNA world that you guys think, and so on. And yeah, like, okay, that took like 30 seconds. Now what are you going to teach? You have 2 weeks. Well, we teach genetics. Right. So. The real agenda. So here's what's really going on with these guys. This is the epigraph of this chapter. Johnson calls his movement the wedge. The objective, he said, is to convince people that Darwinism is inherently atheistic, thus shifting the debate from creationism versus evolution to the existence of God versus the non-existence of God. From there, people are introduced to the truth of the Bible and then the question of sin, and finally introduced to Jesus. So I know Dembski and these guys pretty well, and Dembski, for example, says scientific creationism has prior religious commitments, whereas intelligent design does not. This was in a publication in which he's basically saying